Hi my friends, today we model this assembly which is called engine with flywheel and pistons. Let's start. New standard millimeters IAM, place, and we have components here. You'll find them in the assets. We start with the stand. Double click. Place grounded at origin. But you see it stay in another position. This hole is this hole here. So we have to rotate this because it is made with Inventor 2014. All of them are made with Inventor 2013 in order to offer you the possibility to use them in any other version of Inventor since 2014 to today. I select this corner and I apply set current view as home, fit to view. Now if I select home, you see we have the same position like in the original. Then I place components. The first is bearing cassette. Open, place here. I don't use constraint, I use joint. To know the other tool instead of constraint, we select this face and center, and we also select this face and center. Now take a look. Automatically the part comes in position, and this arrow shows you what is the freedom of this constraint. Okay, place the bearing, ball bearing. Now I make something different to show you what happens. I don't select this face and center because I want to place this here, but I select this face, cylindrical face, and also here cylindrical face. Now you see 2 degrees of freedom you have. We don't need to have this situation, so I use joint. I select any of these 4 circles, 1, 2, 3, 4, but not this. You know why? Yes, because I want to make a contact on this face. I select this, then I go here and I place the ball bearing. Only rotation remains as a degree of freedom. Apply. Now I place all the other components to have them at our disposal. 1, I keep pressed the Control key. 2, 3, 4, 5, 7. Open. Where to be placed? Here somewhere. You see, they are all here, but not. Oh, this is not necessary. It is already placed here. Then I apply joint again for this face and this center to be placed here. You see, only 1 degree of freedom we have. Apply. Another object is this nut. I select this and I also select this. It doesn't come on this face because it was taken from the left, not from the right. This is all. So we have to flip this component to be correctly added. Apply. Another object is this shaft. I select this face and I go here and select this face, and the shaft comes in position. Apply. The washer, there is a washer here. I select also this face, and you'll see I selected the upper face and I place it here. No good. I have to flip that component. Apply. Another part is this one. I select this face and center and I place it right here. It comes automatically and it shows the degree of freedom. Apply. The other objects are not here. Let's get them. Place the curved piston in 3 instances. Yes, you see the 3. Then I apply constraint of this axis, not a face with a point, but an axis, and I place it here in this axis. Oh. This is the way to place it with the constraint, but I don't want to use this. I want to use joint. Now is another behavior. You see, I don't see here an axis. I see a center mid point, and here the same. Important is to see these cylindrical generators. Yes, if you go here, this means to apply insert and not mate. I want to mate them here. I select this cylinder and the part comes in the hole. there are 2 degrees of freedom. One is this and another is this one. Apply. Now I select this axis. I want to understand that I select a cylindrical face, not a plane. And also this. You see, there are 2 degrees of freedom. When I apply that constraint, we have the part placed in position. We continue. This cylinder to be placed in this cylinder. I can select this one, no problem. It comes there and it shows its degrees of freedom. Apply and again apply this with the cylinder. It goes in that hole. Apply. The last is this one, but I made a mistake here. Cancel, Control Z. This must be placed here. Joint this and this cylinder. Apply. And the last is placed in this hole. You see? Apply, and this comes here. I want to tell you that I prefer constraint instead of this automatic and somehow scholastic solution. Okay, now we have all the assembly finished. Now we can apply rotation to the wheel, and you see that this part is rotating as well. We can use this to rotate, and we have this movement. To make an animation, I use the constraint angle, this solution between the flywheel plane, this plane, you see this one, and also you see the angle is 0, and the other is this face. Yes, now we place this in this position. Okay, I cannot rotate anything here, but I have an angle and I can apply drive. What is the end? 360. 360. Start. We have the rotation, direct or reverted, as you can see. You can use other options, for instance, to repeat twice the movement with start and start, and you see what happens. It stops here and goes back. Again goes to back. You can make a lot of things. That's all for today. Thanks for watching. Bye bye. Now comes an interesting topic. What I present here is based on the existence of the components that appear in the assembly. Regarding this modeling, you have two options. One, to contemplate what I do and apply my actions by creating your own components of this assembly. And two, try to create the assembly using the actual components you see in the tutorial. If you want to create this assembly independently, you must, that is, they must be yours, as separate creations that I made for the purpose of showing practical aspects in the tutorial. You can download the components only from assets. Access to assets is done by subscribing minimum to the level Journeyman membership. You see here the levels of membership: Core, Journeyman, Patron, Professional. Excepting Core, the other ones includes the previous ones.